All right, let's talk about example 2. It says this table shows Washington state population in millions from 1980 to 2010. Part A asks us to find the linear model y equals AT plus B for Washington state population in millions, T years since 1980, round A and B to 2 decimal places. So, just like last time, we want to hit stat and then we want to edit our table. I have already entered in the data, so if you have not and need some time to do that, maybe pause the video and then enter those in. Once you have filled out your table, then you want to go back to stat. We want to calculate, and it specifically asks us to do a linear regression. So we're going to go down to option 4, hit enter, and then make sure all of that looks good, which it does, and then we'll hit calculate. All right, so we have our output results here, and I've went ahead and entered in our equation, y equals 0.09 t plus 4.14. Note that our r squared value is equal to 0.9946, which is pretty good. So now let's answer part B. Explain the meaning of the coefficient A and B in your linear model using everyday language. Our A value equals 0.09 signifies that the Washington state population is increasing by, let's see, so 0.09 times 1 million. So that's 90,000. Is increasing by approximately 90,000 people each year. Our B value is 4.14, which indicates that the starting population in 1980 was approximately 4,140,000 people. Okay. Awesome. Part C says find the exponential model y equals a times b to the power of t for Washington state population in millions, t years since 1980, round A to 2 decimal places and round B to 4 decimal places. So I'm just going to clear that, go to stat, just make sure our table hasn't changed, and it has not. So I'm going to go to stat, go over to calc, and then if you go down the list, our exponential regression is the 0 option. So I'm going to go ahead and click that and list 1 and list 2. So that's good. And then hit calculate. All right, so we have our equation there. All right, so I have entered in the equation for our exponential regression. Notice here our r squared value is 0.9928. So again, this is also a pretty good representation or a good model that we have here. So our A value in this scenario is equal to 4.22, and this signifies that our starting population in 1980 was approximately 4,220,000 people in the state of Washington, according to our exponential model. Now, obviously that's if you look at the actual table and the actual data, that's slightly off. There was 4,230,000. This is saying 4,220,000. So yeah, it is slightly off, but for all intents and purposes, um, that is pretty close. Now let's talk about the B value. So B equals 1.0163, and this is the rate at which we are multiplying our population by each year that passes. So, in more mathy terms, that is our growth factor. Okay, so part E says use your exponential model to find Washington State's population in 2020. We want to figure out, that is the same thing as saying t equals, so if 2010 is t equals 30, then 2020 would be t equals 40. So if we go to our table here, first we need to input our exponential function. So I'm going to go to y equals and then press vars and go down to statistics and press enter. And then we want to go over to EQ and press enter. So that is the exponential function that we were dealing with. And so now I'm going to hit table and scroll down to when our input variable is 40, right there. So we can say, according to our exponential model, Washington State will have a population of about 8,060,700 people in the year 2020. Okay. And part F says use your exponential model to determine when Washington State's population will reach 10 million. Again, we can scroll down on our table and kind of just search for when we're going to hit 10 on our output column. So it should be between 52 and 53 years. But I'd say let's go for a little bit more of an exact answer. So I'm going to put y equals 10 here, and then I'm going to graph both of those things just to make sure that it is popping up on our graph. Wonderful. I think my window is a little bit large for the y maximum, so I'm going to change this maybe to 40. That looks a little bit better. Still might be kind of high, so and we actually can't see where these things cross, so I'm also going to need to make my x values larger. So remember, I think it was around the 50s where they intersected, so maybe we could say the max x value could be 70, and the y max of 40 was still kind of high, so maybe we'll make that like 15. So let's see what happens there. Wonderful. That's a lot better. All right, and so now we want to find where these intersect, and that will help us answer question F. So I'm going to hit second, calc, and we want to find the point of intersection. So we could press enter, 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 and then it will give us our intersection point. And so here we have 53.317. So we could say, according to our exponential model, Washington State's population will reach 10 million people approximately 53.317160 years after 1980. Okay,